Find the term independent of x in the expansion of this binomial. So this is another type of question we could be asked with binomials, and we approach it in a very similar way. I'm going to start by writing down what we know, which is it's going to be 9 choose something, and then it's going to be 3x squared to some power, and then it's going to be minus 1 over 2x to some other power. Now here, because we're looking for the term that's independent of x, what that means is when these two bits expand, the powers of x are going to cancel out and we're going to be left with a constant term. Now, it's not immediately obvious how that will work, but we'll do a couple of trial and errors and see what happens. So the important thing is we know that these two powers here, the two numbers in these boxes, add up to 9. So if, for example, this one was 4, this one would have to be 5. Now, if this was 4 and this was 5, this one would give us x to the power of, well, x squared to the power of 4 is x to the power of 8. And this would give us something over x to the power of 5. Now, when these cancel, we're going to get an x to the power of 3, which is not independent of x. So that means that's not what we want. So we don't want 4 and we don't want 5. Given that this power was bigger than this one, we now need to try something where this one is smaller. So let's try 3. If this power is 3, then this power has to be 6 because they have to add up to 9. Then we would get x squared cubed, which is going to give us something that's x to the 6. And here, we're going to get something over x to the power of 6. Now, these are going to cancel. When we get x to the power of 6 divided by x to the power of 6, they're going to cancel out, giving us a term with no x's. So now we've figured out what these two numbers are. We also know this one here is going to be 6. And then we can start working it out. 9 choose 6 is 84. We've already got the x squared cubed, but we've got to do the 3 cubed, which is 27. We've already got the x bit here, but we also need the minus and the 1 over 2. The minus is going to become positive. 2 to the power of 6 is 64. So we end up with 1 over 64 x to the power of 6. Then we do the same as always. We multiply these three terms. So 24 times 27 times 1 over 64. Knowing that these x to the 6's are also going to cancel out. When we do that, we get 567 over 16 as our term, completely independent of x because all those x's cancelled out.